All right, so I'm continuing on in section 1.1 under steam production and putting this curve up here that shows temperature during the addition of heat. That's not very good, so I'm going to redraw it. It happens. And so if I was to plot temperature, it comes up, then it's constant, then it goes up again. And we said this was a sensible heat addition. Sensible heat was where we saw temperature rise. And here we had 60-degree water, and we saw it rise all the way to 212 degrees at atmospheric pressure. Then this is temperature over here on this curve. This is a TS diagram, remember. This is entropy down here, entropy right here. And temperature was constant, and then once again I saw a temperature increase. We called this point the H sub F point. On this curve it would be the entropy once I become a saturated liquid. The water in the pan has become saturated with energy. Any additional heat would cause vaporization until I got to this point. Now I'm at the G point, we call that a saturated vapor. If you're reading along in your lesson plan, your study guide, we've talked about the intro. Now we're at steam production. We've gone all the way through here. First of all, the first note is a sensible heat addition occurs when there's a temperature increase. And then it says, hey, look, once you reach the point of a saturated liquid, the thermometer never reaches 213 degrees. One thing that does occur, though, it says specific volume increases considerably. Sure it does. I was here with a little slug of water in a pan that I was adding heat to, and this is only 1 pound mass. And we're going to see that if I vaporize that all the way over here to this point, the volume that occupies, it's still got the same mass, but it's expanded considerably. Its specific volume has gone up a lot. And then if I added energy to this steam, I would once again see a sensible heat addition up here into the superheated region. Superheated region. All right? So you turn the page, there's some discussion here as heat is added. So as heat is added, water level in the pan is dropping. So this water is going away and steam is now being created. At this point right there, there's 50% water and 50% steam right in the middle. So I've got half steam, half water. Over here, I've turned it all to steam. Very key point. One of the knowledge requirements right out of the gate is essentially a review. Define specific heat. If you'll recall, the symbol for the specific heat capacity of water was C sub P, and it was equal to the change in specific enthalpy divided by the change in temperature. And the units for that were BTUs per pound mass, and for the temperature was Fahrenheit. Good thing to know. We saw two equations, if you recall, where we could use the specific heat capacity of water. One was a heat transfer equation, BTUs per hour, Q dot, equals, well, M dot, which is the mass flow rate, times the specific heat capacity in BTUs per pound mass degree Fahrenheit, times T hot minus T cold, the difference in temperature between two things. There was limits on this. One limit I told you about. Can you remember? That's right, no phase change. You can't use this equation when there's a phase change occurring. Remember that. We'll get on with section 2.0 here in the next video.